Dear students, welcome to the problem solving session on Gauss Divergence Theorem Part 2. In Part 1, we verified Gauss Divergence Theorem for a given f vector bounded by the over the Q. In this session, we are going to solve a different problem. Verify Gauss Divergence Theorem for a given f vector over the rectangular parallelepiped bounded by the lines x0 to a, y0 to b, z0 to c. As usual, we go by stepwise. Step 1, let us write the given f vector, and then step 2 is going to be my limits. Before going to the limit, let us visualize the problem. Take this as x, y and z axis, and here we mention I vector in this direction, j vector and k vector. So I'm drawing a rectangular parallelepiped. This is going to be my origin 0, 0, 0, and it is clearly mentioned x lies between 0 to a, y lies between 0 to b, and z lies between 0 to c. Therefore, this length is going to be a, and this is going to be b, and this is going to be c. So we have to mark the vertices a 0 0 in x-axis, 0 b 0 in y-axis, and 0 0 c in z-axis. Hope you visualize the problem. Now let us write the limit. The limits are going to be 0 to a for x, 0 to b for y, and 0 to c for z. Step 3 gets over. Next we are going to verify Gauss Divergence Theorem. So we have to write the Gauss Divergence Theorem statement. Double integral over s f vector dot n cap ds is equal to triple integral over v del dot f vector dv. And as I repeat again, S is a closed surface, and dv you can choose in any order. I am going to choose dz, dy, dx for my convenience. Next, after this, we are going to take RHS first, and then we come for LHS. So to take RHS, we need del dot f. Our next thing is to RHS, we need del dot f. Let us calculate del dot f. So take the f vector. Del dot f is going to be my divergence. It is very simple. Dou by dou x of x square minus yz, dou by dou y of y square minus xz, dou by dou z of z square minus xy. Now differentiating this partially with respect to x, y and z, we will be getting 2x here in the first term, 2y in the second term, and 2z in the third term. Therefore, del dot f vector is going to be 2x plus 2y plus 2z. You can see the typed version. Next, we are going to calculate my RHS. That is my step 4. So as I said, I am going to take dz, dy, dx. And del dot f just now we found it is going to be 2x, 2y, 2z. So let us write the limit dx. So outer integral is 0 to a, then dy 0 to b, then dz 0 to c. Now we are going to integrate this one by one. While we integrate with respect to z, x and y are constant. So integral 0 to a, integral 0 to b, 2x integration is 2xz. Similarly, 2y integration is 2yz, and 2z integration is 2z square by 2, integral 0 to c, dy, dx. Next, we have to substitute the upper and lower limit, and we have to simplify it. When you substitute the lower limit, it becomes 0. When you substitute the upper limit, we'll be getting 2xc, 2yc plus c square. Next, we have to integrate with respect to y. While we integrate with respect to y, x is going to be constant. So we'll be getting 2xc y plus 2y square by 2 c plus c square y. Applying the lower and upper limit, we'll be getting 2xcb plus b square c plus c square b dx. Next, we have to integrate this with respect to x. While we integrate with respect to x, we'll be getting 2x square by 2 bc plus b square cx, bc square x 0 to a. Substituting the limits, we'll be getting a square bc, b square ca, bc square a. Rewriting this, we have a square bc, abc square plus ab square c. So I can take abc in common. We'll be getting abc into a plus b plus c. This is my RHS. Now we are going to do calculations for LHS. As I said, it is a rectangular parallelepiped. It has 6 surfaces. We are going to do one by one. From problem 1, you remember what are they? 6 surfaces. Front, back, right, left, top, bottom. So take the axis first. For the x, we have front and back. So in the problem, it is given as x equal to a and this is x equal to 0 as their equations. Therefore, the first surface represents the front and the second one represents the back. Next, for the y-axis, we have right and left. According to the given question, y equal to b is this equation and y is equal to 0. So let us write S3 and S4, right and left. And finally we have z-axis, top and bottom. For this we have z equal to c and here we have z equal to 0. So my S5 and S6 are top and bottom. Front, back, right, left, top, bottom. Done, students. If you evaluate this 6 regions, we can get our LHS. To solve the problem in a simpler way, as I said, we have to go for a tabulated form. Now first write the given vector and we have to take a 7 cross 7 table, 7 rows and 7 columns. First we are going to fill the surface, then the face, equation, n cap, because we have to find f vector dot n cap. So I'm filling n cap first. Then we have f vector here, f vector dot n cap. Then from the equation we are going to substitute the values and we are going to write the values also there. Then ds. We have to choose the limits for the integration. Now we have 6 surfaces, S1, S2, S3, S4, S5, S6. As I said, S1 and S2 are front, back, S3, S4 is right, left, S5, S6 is top, bottom. And we know the equations very well. So for front, back, we have X, right, left, we have Y, top, bottom, we have Z. So for front, right and top, we have to give the upper limits. So X equal to A, Y equal to B, Z equal to C. Remaining thing automatically we have to fill the lower limits. Here it is 0, 0, 0. Done. Now we have to view the unit outward normal vector. See the x-axis. We say this is my direction. I is in this direction. So the unit outward normal vector is perpendicular to this surface. So this is I vector. For the other surface, the unit outward normal vector is going to be minus I. Similarly, for the right surface, we have j vector and for the left, it is going to be minus j vector. And for z, this is going to be my k vector and here minus k vector. All these things are for your visualization. Just to understand the table in a simple way. I said we can easily fill the n cap. I, j, j, k, k. For front, right and top, we are going to put the positive sign. Back, left and bottom, we are going to put the negative sign. Done. Next, f vector is there, n cap is there. We have to find f vector dot n cap. When you do the dot product, we will be getting x square minus yz. For minus I vector, we will have minus of x square minus yz. Similarly, we have y square minus xz and z square minus xy. We can easily write this 1 by 1. Done. Next, values. So substitute the equation in corresponding f vector dot n cap. Here x value is a, so we'll be getting a square minus yz. For the second one, x is 0, so minus of minus, it is going to be plus yz. Here b square minus xz. Here y is 0. We have minus xz, minus into minus plus xz. Similarly, c square minus xy. The last term is xy. Done. For the surfaces x, we have the limits y and z. So dy dz or dz dy. You can fill in your own way because all my limits are constant. Next, for the y surface, we have to write dx dz. For z, we have to write dx dy. Now the table is done, students. In the previous problem, we know S2, S4, S6 is 0. So we just calculate only 3 surfaces. Here, none of them is 0. See, all the values are non-zero. Now, you may think that immediately we have to calculate S1, S2, S3, S4, S5, S6. It is waste of time. Just think, students. S1, S2, it is having the same limits and dy dz, dy dz. So, instead of calculating S1 alone, I am going to club like this. S1, S2 together, S3, S4 together, S5, S6 together. There is a reason. If you club this together, that means if you are adding together, my yz minus yz will get cancelled. Here, my xz and minus xz will get cancelled. Similarly, minus xy plus xy get cancelled. My problem is going to be very, very simple and I am going to do only 3 integration. So I can make the problem very simple. So let us do this. First we have to integrate the region S1 and S2 together. So double integral dy dz or dz dy. So I am going to take dz dy. I am going to take dz dy. From the table, the values are a square minus yz and yz. A square minus yz plus yz. So these two will get cancelled. My problem is going to be very simple and the limits are going to be 0 to b, 0 to c. Now I'll take this a square outside. Now integrating with respect to dz, we'll be getting a square integral 0 to b, z 0 to c dy. Substituting the limits, we get a square c. I'll take the c outside. Integral 0 to b dy. Integrating dy, we'll be getting y. Substituting the upper and lower limit, we get a square bc. Listen students, if you evaluate this s1, s2 separately, that is also correct, but it is time consuming. We have to do 6 double integrals for 6 surfaces and we have to add. Now the business is very simple. Next, in the similar way, I am going to add s3, s4. Double integral, I am going to take dz dx. From the table, we can see f vector dot n cap is b square minus xz and xz. Dx dz. b square minus xz plus xz. The limits are going to be 0 to a, 0 to c. Now, xz get cancelled. I'll take this b square outside. Integrating with respect to z, we'll be getting b square integral 0 to a z 0 to c dx. Substituting the limits, we'll be getting b square c integral 0 to a dx. Integrating this with respect to x, we'll be getting x. My lower limit is 0, upper limit is a. So a b square c is going to be my answer. Next we are going to calculate for the surface S5 and S6. For this, we need the data from the table. We can see here f vector dot n cap is c square minus xy for S5 and xy for S6, and ds value is going to be dx dy. So either you can take dx dy or you can take dy dx. So double integral, I am going to take dy dx. So my limits are 0 to a, 0 to b, c square minus xy plus xy. I am adding both the surfaces. So minus xy plus xy get cancelled. We'll be having c square alone. Take the c square outside. Now integrating with respect to y, c square integral 0 to a, dy integration is y, integral 0 to b dx. Substituting the limits, we'll be getting c square b integral 0 to a dx. Integrating this, c square b into x 0 to a. Applying the limit, we'll be getting ab c square. So now in 3 steps we found all the 6 surfaces. We have to add this. Double integral over s f vector dot n cap ds is going to be the summation of all the 6 surfaces. A square bc plus ab square c plus ab c square. Now we can take ABC in common. Therefore, my answer is going to be ABC into A plus B plus C. Therefore, my RHS is also ABC into A plus B plus C. I get the LHS, that is also equal to ABC into A plus B plus C. Therefore, Gauss divergence theorem is verified for the given rectangular parallelepiped. Next, we are going to give the quick summary. For a given problem, step 1, take the F vector. Step 2, write the limits from the question. Then visualization. Step 3, write the Gauss divergence theorem. Now we have to evaluate RHS. For this, we need del dot F vector. Calculate it. Then step 4, RHS. We are going to integrate the triple integral over V and we get the answer ABC into A plus B plus C. Next we have to go for the LHS. It has 6 surfaces, front, back, right, left, top, bottom. So we are going to fill the table for the given problem successfully. From the table, we are going to club this S1, S2, S3, S4, S5, S6 for simplicity. So we'll get the answer A square BC for first 2 integrals, A B square C for the next 2 integrals, and AB C square for the S5 and S6. While we add and simplify it, my LHS is ABC into A plus B plus C. Therefore, my LHS is equal to RHS. We have verified the Gauss divergence theorem. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.